My name is Daniel Young. I have made a few different light-based art projects. I started in about 2016 with a gazebo that was kind of fully enclosed, and I was a part of that project, and the kaleidoscope in the center, and that was kind of where this is the background here is the gazebo. This is me at Maker Faire 2019. I brought art to a bunch of different places. The biggest one that we ever did was I think 23 feet, like pyramid that went to EDC, which is in Vegas, kind of a more mainstream but very big festival. We made a thing for that. Locally here is Fathom by Roboto Octopato. They just recently shut down, actually. They had kind of a temporary building situation in downtown Portland, and it was undersea themed. It lasted about a year and a half and was doing great, but the city just wouldn't extend the permit anymore. So they shut down, but that collective, Roboto Octopato, is going to continue making things for the Portland area. It's all local people, kind of bootstrapped from essentially no budget to build Fathom to, I think it's going to be really cool. I think in a few years we'll have a couple of bigger, better installations, and they're very immersive and fun. The treasure chest that's in there was in Fathom, and it's like there was a bunch of treasure chests kind of strewn about the place, and so I got to do one, and you can kind of open it up, and there's a sleeping dragon in there that a friend of mine sculpted, and he's kind of sleeping amongst his treasure, and then the spinning thing in the center is based on this concept. And so this is Melty Cube. It was kind of the first one. I call it Melty Cube because I originally 3D printed a bunch of parts, and I took it to a festival and left it in the car, and it was PLA. Everything melted. And then it also has some little bit of brain melting capability as well. So it kind of, the name stuck. I kind of like it. So this is Melty Cube. And its original design, and this is the first, this was the first thing that I built with this effect. And so the fun part about it is that it's kind of a noodly little toy. I can take it around with me. This part is just for today, so I don't have to hold it. It does this fun persistence of vision effect, right? And I wish we had a little less light. I think we're getting some from over here. But you can see how the gears are moving. We've got these like little teeth moving around. It can kind of do this like physics-defying jump back and forth. And when I take this thing out, it gets a lot of questions, and it does a lot of kind of pretty things, and people say, I get a lot of the same questions, honestly. And I think Scott put it really nicely earlier, where there's a certain amount of where you can suspend just enough, you can confuse people about how things are working just enough that it really amplifies the immersive quality and kind of psychedelic nature of things, and I like that. So this is Melty. I'll put it on auto mode here, so it should just do its own thing there. Okay, and so I get some very common questions, so I figured I'd just put them all on some slides, talk about them. First one is a general question: what exactly is going on here? And I get this from and it's a hard one to answer because I'm not sure what they're talking about usually. I like to say it's kind of a little mix in between these, like this imperfect persistence of vision effect that we get from like these concert things that are $1 or whatever they hand out for free, and this, like, I'm sure you've seen these advertising, they're kind of a spinning fan with LEDs on it, and like the range between these things, this is a $1 toy and this is a $300 toy, is the slop, like the kind of messy, diffused, just pure blinking, to this like perfection, essentially. Like what you've got there is like LEDs spinning around in space with a perfect rendering of exactly what you want them to display. And I would argue that Melty Cube is sort of in between there. It's diffused light, it is messy, and I think that's what makes it artful. And it is not perfect. And in fact, a lot of the things that I originally intended to do to this, I never even did, because I kind of liked a little bit of the, I don't know, the more experiential nature of it. Like this, the way it works is it has an ESP32 here and another one in the box. And so there's actually a power supply in here, and I'll get more into the architecture of it. But it's all controlled by my hand. So I use this little menu system to kind of like noodle around on what it's doing. And it creates kind of a bit of a show, and it lasts only a certain amount of time, and I think that's nice for an interaction. I usually take it to festivals. I'll take it to the Life Festival. I take it to like a music festival. I'll just take it out when I think it seems appropriate, like a concert or something. And people really, really respond to it, because it's something that you haven't really seen that much of. While I noodle on it, you know, it kind of gives me a chance to see what I can make it do, because I've got like a bunch of parameters here that I kind of will toy with, and you can kind of see some of the effects that you get. Over there, you'll see like there's 3 or 4 other boxes that I've had. So the cube itself, I've made a bunch of different versions of that. The original ones were mostly designed by my friend Keenan, who does like sacred geometry art. Second question I get oftentimes, and this is usually a chance to talk about consent, is can I touch it? And no, please don't touch it. It usually does fine. It's wood and acrylic, it's like an acrylic box with wood. So this is another one. Isn't this that effect? And they work on it for a minute, and there's a few of them. And the main one that I think that covers more broadly, and I'll go into all the different ones, is persistence of vision. And persistence of vision is such an old trick that Da Vinci was talking about it. He mentions, lightning moves among dark clouds, the speed of sinuous flight makes its whole course resemble a luminous snake. So he's noticing it in nature mostly, or somebody with a stick and an ember of flame swinging it around is probably, I'm sure, was some of the earliest things that we did, together as a people. 16 AD, here's Ptolemy just talking about, he wrote a whole book called Optics, talking about a rotating potter's wheel. Aristotle, this is 300 BC, that's crazy, he's talking about it. And then he's noting that the sun remained his vision. This is when humanity learned not to stare at the sun, and everyone except the worst and toddlers among us have learned that. These names are all obviously famous names. This Michael Faraday, if you're familiar with the Faraday cage, wrote this. One of his first papers was on a peculiar class of optical deception. So I titled the slide after that. And so persistence of vision is the main one, right? And so the persistence of vision is essentially the illusion that a light source persists for a brief moment longer than it actually does. And our brains can interpolate enough to where things that are blinking can start to, or just are lit in general, will start to merge together. And this is kind of the overarching concept, right? That covers all of these different things. There's also, a lot of people say, zeotropic or stroboscopic. So zeotropic specifically is the zeotrope, and I might be pronouncing that wrong. It might be like zoetrope. But that was like some of the earliest methods of animation, where a little slit with a rotating animation inside, and through the slit with just a consistent light source, you could see a little bit of an animation. And so that was interesting, and we quickly moved on to the stroboscopic, which I think a lot of people say zoetropic because of the style of art, but it's really stroboscopic most of the time. You usually use a consistent spinning, flashing light to create shapes. And then there's the classic this is another one that people say a lot, is the wagon wheel effect, which is what you see when you look at a propeller on an airplane, where you see it kind of reverse and go backwards for a second. And I think arguably, like between these three, it's kind of all of them, right? So we actually can kind of demonstrate each of the effects. So the fact that it's advancing or not advancing, right? So that is the wagon wheel effect. If you time the light just short of a perfect revolution, then you get a kind of physics-defying jumping around from left to right. And then the stroboscopic itself is the animation that's happening here, is these little gears are moving, the inner one's moving. This is really the first one that I've animated more fully, and I was a little bit conservative with what I could move in there because I was worried about the jumpiness of it. There's one in there that's got a little Burning Man guy, and he's got like 4 arm positions because you get 4 faces of the cube. So you get 4 animation frames. So some of the things we learned with zoetrope, if you've ever seen one of the zoetropes, the big ones, where it's like the same animation, but there's like 12 of them or whatever. It's a trick that I'm using here, which is that my gear is not obviously turning around one full circle. It's really only going 1 gear tooth. And so from one to the next. And so you match from, and that's essentially how the zoetropes generally work, is you merge a shorter frame of animation with a secondary set with the same number of frames, and you get a multiplier effect. So I'm actually really excited to kind of like explore that more. I think there's a lot more potential there. And I was a little worried about doing that inner gear because I was worried it'd get choppy in it. And so there's a bunch of, I don't think I ended up putting that in here. But yeah, so it's a persistence of vision. It's stroboscopic for the animation. It's zoetropic style art techniques. I think most zoetropes are actually stroboscopes. And, but the technique to like have the animation merge into the next is zoetropic art. And then wagon wheel, and there's also like temporal optical mixing, which is like where you get additive colors. So it's kind of fun to show the top. So like up here, you can kind of see how the colors start to overlap. You get these like interesting additive colors, and depending on what I have some other like effects that can like do a little bit more color mixing. So anyway, it's kind of all of them. And so really, I guess I can just start saying yes, like whatever they say. Yeah, but essentially it does that in one. And I actually kind of found that out as I was doing this presentation, like what are we actually, what is exactly this called? Because some people, there's some difference there. So what makes a change? So what's happening here? Generally speaking, it's spinning the same speed the whole time, and that's much easier. You don't have to control a motor too complex, just set it to its speed. A lot of people think that the motor is changing speeds itself when you get the like still cube, or that it's stopped. It's not. What I'm controlling is the properties of basically a square wave and the duty cycle that we do there. So the 3 parameters that I have is frequency, so how quickly each spike in the square wave is coming through, and the light is turning on, and it's advancing 1 frame. So every time it turns 1/4, it's moving the color that's on that face 1 turn as well. So the lights are running against the rotation, and the flashing is basically just this. So when I use the frequency knob, that's what's making just 1 cube or 2 cubes or like, I don't know, maybe 6 cubes, I'm not sure. And then into this like more trippy mess of weird colors. And so that's what I'm doing. This is a very high frequency. As we go this direction, it starts getting blurry and a little more hard to look at. But if you look at like the top, see how the cube is like getting wider because the light is on for a longer period of time. And so when I turn it down, you should see the box like starting to reappear as it becomes the on time. That's what I call that. And that's basically how it works. And then the third one is color. I can, just kind of like sweep through the rainbow. So each side is sort of just an offset of the rainbow, and you can do some fun stuff there. And when it's at that higher frequency, it's kind of a mess of a color. Oh, can I take a video? No. Well, you can try. My answer is you can try. Here's a good example. So a common cell phone will run at about 30 frames a second. And what you end up with is this extra blinking in there when the syncing of the 30 frames per second matches up with my sort of slow. It's not even really it's probably about 20 frames to 30 frames per second as well. So when you get those, when the shutter is off and the cube is off, and it comes back on when the cube is still off, then you're getting these like dropped frames basically. So it's really hard to videotape, and like, if you add a compression to this, so if you put this on Instagram will also try to do something with these missing frames and try to do weird compression stuff, so it gets even blinkier, right? Like, I don't even know, it's the properties of compression, it's probably like keyframes or something. Anyway, how is it built? So this is the inner bits of this one. So this is the controller I'm using here. This is like an older version. With a different screen. It's got an encoder, so I can click through the menu instead of having like a ton of knobs. I just have one knob and I click to the, it's a little slow, but I actually am looking at that Trill one because it would be fun to just put that in there so you could do like a little more slidey action, or a couple. Inside is this core. It's got a little hollow aluminum corners, and just regular LEDs, well, pretty regular. The normal ones you see most of the time are 282012B LEDs, which are a 3-wire system, so data, power, and like 5 volts or 12 volts. These are APA 102s, APA 120? 102s. 102, okay. Yeah, and so they have a clock and a data signal, and the nice thing about that is your microcontroller can run the clock at a much higher rate, and you get a more consistent signal, and you can also just run them at higher frame rates. So these are often in a persistence of vision. They're like the POI and the LED toys and stuff like that will have this type usually. This is kind of the motor mount here. So this right here is a drone motor. It's a little bit of a slower one, it's 400 kV, and it's mounted on the bottom there. And so there's a separate battery system just for the motor. So down here, there's a couple of 18650s, and I just kind of cord it out. This is my first stick to do, so I'm actually in the process of kind of like redoing this much cleaner. It's fun. I can like show everyone all the parts. And I am endeared to this one, but I am trying to like make a nicer version. I'll do it eventually. I got some bits in there, and it'll collapse, and one of the things that's a pain is to just put it in the car. So I'm gonna make a little and putting it on a plane has been interesting too. I figured out I can pack it as a fishing pole and tackle box, and the plane they'll take that and they count it as one checked item, hey. Anyway, a little more about the controller. So this microcontroller in here, is just, this is another ESP32 we're talking about a lot today. It's got a little built-in OLED screen, and behind there is like my encoder, and there's a switch here. And it talks PWM, so to what's under here, which is just basically a drone speed controller. And some of the other projects have used more advanced motor controls, but these are cheap, and like a typical drone takes 4 of them, so they're pretty readily available. People will throw away and replace their the motor systems on their drones, so or like one will burn out and they'll buy 4 new ones. So they're everywhere. And so it just talks PWM. So this microcontroller uses the regular off-the-shelf Arduino servo library to send out a PWM signal, and that controls how fast the motor's going. So that's one battery system, and then there's another one inside here. So there's like there's an 18650 sitting in there, and a microcontroller with a switch up here. And that's pretty much it. Like the box is acrylic and wood, it's laser cut. So I've made a few different form factors. It actually ended up being 3 in the treasure chest, and this is 4 sides. Fractal flow here is like a sea urchin skeleton. It's kind of going for there, and that's 5 sides. And this is tops, is in the Winter Light Festival. It's like a window display with 3 of them. I'm pointing at the wrong thing. Yeah, so this is tops. So 3, 4, 5, 6. And what I found is the round ones are interesting, but everything ends up round once you start spinning it. So like the 6, like the more sides or the more complex, you just get closer to a round shape anyway. So I kind of actually, my favorite is still the 4 because you have this negative space in here that is kind of interesting. Like if you look at it, well, like on its side, I don't know if you can see it. It's got kind of these like ghosting effects and that kind of hang out in midair that I kind of like. And so, you know, the more size, the more complex, it always just ends up round anyway. So I've kind of tried a few different things and ended up right back here at 4. So that's it. That's my presentation. Thank you. And we can go in there and I can just talk about the other ones if you want. This is the frequency. You can kind of play with it, and my clicking isn't always the best. That's the on time one, so you can see how it's getting kind of blurry. And then there's color. Whoa. Whoa. Yeah, so like there's the color transitions. So that one's fun, and yeah, it's kind of like a surprise. You pick up, you can open the treasure chest and it should turn on. Yeah. And this is the most recent one I built, kind of trying to go a little bigger. This one, I took it to soak the kind of regional Burning Man thing. It actually hangs in the ceiling of a larger dome. I would have liked to put it together today, but it was kind of too much. This one's kind of fun and like a beefcake. Like I kind of overbuilt it with the intention of having different art pieces to go on it. So this is like a rather monstrous brushless motor with an O drive on it and runs at 24 volts. So this thing could like also do a little e-vehicle, right? Like it's a big one. It's all running basically the same software. I've got to clean some of this stuff up. This is a hollow shaft, and this one, the kind of fun thing about this one is the slip ring that's in use here. This one is basically 2 bearings with a pool of liquid, of mercury in the center, and the 2 poles just are sweeping through like a pool of mercury. It's a mercury slip ring. Some guy told me about that. I was like, oh, I'm gonna buy one of those. And sure enough, he was like, that's what we used to use back in the day for that sort of thing. And I was like, oh, cool. And I looked it up, and sure enough, like they come out of China. They're not even really that expensive, and they'll take 30 amps and is essentially no longer a wear part because it's just a couple of bearings. So kind of nicer. So this is a more typical slip ring. So this is kind of my next gen one that I'm hoping to kind of clean up the design. One of the things I mentioned about the offset drive, right? You have to have a motor here and the slip ring. So you have your wires coming in, right? This is where you're communicating with the LEDs or microcontroller. Then you have the shaft and it can rotate. Okay, so that's like a nice slip ring. This is a pretty good one, and it's got nice centering pins. The ones from Adafruit are still 30 bucks, 40 bucks sometimes, and will wear out quickly. But essentially there's a bunch of little contacts in there. It's just kind of like a brush motor or something. This one's kind of neat though, because it's a hollow shaft motor. So the beauty of this one is you can do like a fully inline implementation, because this is like a custom, my own shaft. So that's kind of cool. I'm excited about this one because I think I could kind of do a little more small, like desk toy style. This is my new stick in the process. I'm like do aluminum sections like that. And I need to make it look nicer, but other than that, it should hide a little things. The batteries will just go in there. And that'll hopefully be kind of swappable and etc. This is the same kind of motor. So that's a work in progress. And yeah, this is tops. This is the 6-sided one. This is the first time we tried some animation. We were just using like line weight changes to make it kind of pulse. And this is the core, it's 3D printed. So these are LEDs, kind of similar. And it sits on like a shaft and runs in like a shelf, basically, inside a window. Here's the prior art. This is the Burning Man one. This guy, he like flaps like a crazy like insect or something, because that was too much motion. The sweep is too large for the frames. And this was the original. This is like my buddy Keenan made both of these. And these ones are actually really beautiful. Like I'd actually like to get closer back to this design. I was kind of just toying with the animation on this one, but this has a lot of really interesting effects too. And that's it. You can, any questions?